Today we're going to take the number 37 notes, approximate solutions, and we're going to use Desmos to find solutions. So you should either have your phone, because you should have already downloaded Desmos onto your phone, or two screens open on your computer so you can get to Desmos. So www.desmos.com. Okay, so here's how it's going to work. If you have f of x equals 18x to the third plus 12x plus 6. So that's one function, 18x to the third plus 12x plus 6. And then you have another function, g of x equals x minus 1. Okay, so we're going to do two problems with these particular ones. The first thing is I want you to find when does f of x equal g of x. So when does f of x equal g of x? Now we've already done this by hand. But what we're going to do now is we're going to learn how to do it with Desmos. So what you do is in Desmos, or you can use a graphing calculator, but it's a little bit harder with a graphing calculator to find the intersections. There's a little bit more work you have to do. Desmos makes it super easy. Plus on the EOC, you would have access to Desmos. But it's y equals, so you're going to do y equals 18x cubed plus 12x plus 6, and then you're going to do another y equals x minus 1, and then you're going to find the intersections. Find the intersections. So if I go to Desmos and I plug in y equals 18x raised to the third power, and then you have to arrow over, plus 12x plus 6. So there's one equation. And then I do the other one, y equals x minus 1. Now just so you can see, over here there's a graph setting. So you can, normally you'd want to step by one. You can put arrows on them if you want. You can do grid lines or no grid lines. Grid lines are better. You can do projector mode or not projector mode. Not projector mode, the lines aren't as dark. But I like to step by one. So step by one here and step by one here. So it just makes it a little bit better. And you can also zoom in and out. So you can zoom out, or you can zoom in, or you can literally just move the graph around with your mouse. But if I zoom out, what you'll basically see is they're only intersect in one spot right there. So if I zoom in, all right, they're intersecting right here. So if you just click on where that is, then you can see their intersection is negative 0.468. So that is your answer. You only want the x value. So where do these two graphs intersect? 18x cubed plus 12x plus 6, and then x minus 1. They intersect in one place, and you're going to use the x value. So let's go back to here. All right, so you couldn't really see it much, but it was some sort of disco, and then you had this graph, but they intersect right here, and the point was negative 0.4, what was it again? Negative 0.468. 68, and then the y was negative 1.468. Okay, going back here. Okay, but the only thing we want is the x value. So that's your solution, negative 0.468. So that's our answer. All right, so that's where those two graphs intersect. All right, now if I wanted to do another one, but I wanted to find when f of x equals 2 of g of x. So you're literally doubling g of x. So the way you're going to put that into your calculator or Desmos is y equals 18x to the third plus 12x plus 6. But then for the next one, it's literally 2 times whatever g of x is, or whatever it is, you have to put that whole thing in parentheses. So it's 2 times all of g of x. So if it was 2 times f of x, it would be 2 out here, and then in parentheses, all that would have to be in parentheses. So when we go back to here, then what I need to do is put a 2 right here, and then put that in parentheses. And then, so where's the intersection? So now, the intersection is at negative 0.531 and negative 3.062. So that's the point of intersection. However, we only need the x value. So here, where does f of x equal 2 of g of x? At negative 0.531. So that is your solution. It goes out to the tenths, hundredths, thousandths place, so just go out to the thousandths place. That's fine. Just desmos will round to the thousandths place, so you can just have your answer go to the thousandths place. So let's try one more. In this case, if f of x equals 1/5 x cubed, 1/5 x cubed plus 2x squared, and g of x equals x plus 2, we'll just make it simple. All right, so here I want you to take those two, and I want you to find when f of x equals 1/3 of g of x. When does f of x equal 1/3 of g of x? So again, you're going to go into your desmos or your graphing calculator, whichever one you're using. 1/5 x to the third plus 2x squared, and then you're going to go 1/3 times all of g of x. So the whole function, x plus 2. So we go back to desmos. Get rid of that, and we have, okay, so I'm going to put 1/5 in parentheses like that so it doesn't get confused. 1/5 x raised to the third power, and you have to arrow over, plus 2x raised to the second power, and then down here you have y equals, and then I'm going to put 1/3 in parentheses, 1/3. Just do it like that. I guess it put those extra parentheses in there, but that's okay. And then you're going to have x plus 2, x plus 2. All right, so there's f of x, 1/5 x cubed plus 2x squared. When does that equal 1/3 of g of x? And g of x is x plus 2. So if you look here, they intersect right here and right here. So you can click on those, and then there's your solutions. So I'm going to just draw and then so x is negative 0.511 and also 0.643. So what I did was on my paper, I just kind of drew what was happening. It was a parabola, or at least it looked like a parabola at that point, and then they intersect right here. They intersect right here. And so that was at negative 0.511, and that intersected negative 0.643. But that might not have been it. So if we go back and look at it, I might need to go out a little bit more. And look, I did need to go out a little bit more, because look what actually happened. It's actually intersecting it at 3 different places. So not only is it 0.643 and negative 0.511, it's also at negative 10.132. Negative 10.132. So if you come back here, just draw like a little disco. Mine's not very good. Draw like a little disco, and then mark that it intersected in 3 places. So negative 10.132 0.131, negative 0.511, and 0.643. So it intersects at 3 places, so I have 3 answers. So try to zoom out for a little bit. And if you actually watch it, it'll zoom out. I mean, you can zoom out pretty far, but when you zoom too far out, look, that's all the way up to 500. That looks like a straight line. So then you can zoom back in. So zoom back in, and then you can, that's not real clear there, so you keep zooming in some more, and then that's too much. So there's your 3 intersections, and you want, again, the x values. So there's that. All right. So again, just take them and put y equals the function, and then if it's like 1/3 or half or whatever, you're going to put that in front of the function in parentheses. So there's that. And then, so that's the first part of your notes. The second part of your notes has to do with exploring graphs. So compare graphs and equations. Compare graphs and equations. All right, compare graphs and equations. Okay, so for this next example, I want you to do me a favor. So you're going, first watch me draw this, and then I'll give you a second. So go out like 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 1, 2, 3. And then what I want you to do, you can do it with your pencil. Draw a dotted line right here, because that's going to be an asymptote, and our graph is not going to cross that line. It's called an asymptote, and we'll get into that a little bit more later on. But you're going to have what I call a butterfly. So you're going to have a line that looks like this. It's going to get really, really close to -2, but it'll to 2, but it'll never touch it. And then this line will get really, really close to 0, but it'll never touch it. And then you'll have a line that comes in here. It's going to get really, really close to 0, but it's never going to touch it. And then it's going to get super close to 2, but it'll never touch it. So on this particular graph, when you look at it like this, what happens is 2 is an asymptote. So your domain on this graph, your domain is all reals, but x cannot equal 2. So x will be any other number you can possibly think of, but the only thing it cannot be is 2. So when you look at that graph, that's what it's saying. X can be any value except for 2. So go ahead and get that graph drawn, or pause the video a second and get that graph drawn. It's really important that you can clearly see that it's getting close to 2 here and getting close to 2 here, but it's never going to touch it. All right, so here's the question. The question is, excuse me, which equation has the same domain? Has the same domain. Which equation has the same domain? So it's going to be multiple choice. The first one is y equals x plus 2. The next one is y equals x minus 2. C is y equals 1 over x plus 2. And then D is y equals 2x minus 3 over x minus 2. Okay, so what you can do here is you can actually put this in desmos if you want, and I can just do it right here. If you do y equals, let me clear all these out, y equals x plus 2, and look at the graph. The domain is all reals. So this domain right here is all reals. Same thing's going to happen to x minus 2. So if I do x minus 2, and look at the graph, it's also going to be all reals. There's nothing that's going to stop that. But if I do y equals, alpha y equals, let me make a fraction, 1 over x plus 2, and look at the graph. Look what happens. This graph gets really, really close to -2 but never touches, and really close to -2 but never touches it. So that one, this one is also, the domain is all reals. We already said that one. This one, the domain is all reals, except, and we've talked about this before, what's going to give you 0 down there? And what's going to give you 0 down there is when x equals -2. So x can be any number except for -2. But if I look at this one, the domain, same idea, the domain's going to be all reals, but what can x not equal here? And what's going to make that a 0 in the denominator is +2. So if I actually go to graph that one, and on top I put 2x minus 3, and on the bottom I put x minus 2, and then graph it, then you can see that it's going to be -2. And if you actually look at the table and you go to -2, oh, I have it on ask, but if you go to -2, or +2, sorry, +2, it says error. If I put in a +2, it'll say an error because it cannot equal +2. So there you go. Let me put it back on auto. All right. Okay, so there we go. So this one x cannot equal 2, and on this one x cannot equal 2. So which equation has the same domain? And the answer would be D. Number 5, you have, go down to -3, 1, 2, 3, 1, 2, 1, 2, 1, 2, 3. Okay, now we're going to draw another asymptote, but this time it's going to be a horizontal line through -2. And so we're going to draw an exponential. It's going to get really, really close to -2, but it's never going to touch it. So here, your range on this graph, the range is going to be from -2 up. So y is just greater than -2. It's never going to equal -2. This gets closer and closer and closer. So the range here, you can just say y is greater than -2. Not equal to, just greater than -2. All right, so in this one, we want to see which equation has the same range. Which equation has the same range as the graph? Has the same range as the graph. So again, you can put each of these either in Desmos or your graphing calculator, whichever one. So we can do the same thing here. So if A is y equals x squared minus 3, B is y equals 1/2 to the power of x minus 2, and then C is y equals the absolute value of x plus 2 minus 1. Now, you all should already know what's going on right here. This one is going to be a quadratic that's literally moved down 1, 2, 3. So it's going to be down here. So this range would be y equals, y is greater than or equal to 3. So if I actually put that in my calculator, x squared minus 3, and look at the graph, you can see it goes down to -1, 2, 3. So your range here is y is greater than, the range here is y is greater than or equal to -3. So it's not that one. All right. Let's try this one. That's an absolute value, and it's gonna take that absolute value. So if I have an absolute value here, it's going to take the absolute value and it's going to move it to the left 2, 1, 2, and down 1. So here, my range would be y is greater than, y is greater than or equal to -1. So if we wanted to put that in the graph, hit math, num, absolute value, x plus 2, and then -1 on the outside. If I look at that graph, you can see exactly what I said. It moved it from the here, and it went over 2 and down 1. So that this range on this one is y is greater than or equal to -1. So now let's look at this one. Y equals, I'm going to put in parentheses, 1/2. That is not what it looks like. 1/2. 1/2. And then raised to the power of x, not 2. Goodness, I'm just messing up everywhere. X. Let me clear that out. So raised to the power of x minus 2. So look at this graph. It's going to get really, really, really close to -2, but it's never going to touch it. It's going to get really close to -2. It's never going to touch it. If you actually put this in desmos, it'll look much better. So this range is y is greater than -2. Y is greater than -2 because it's an exponential. So which one has the same range? And it would be this one. So our transformations, the things we learned from our transformations will help us with this. And then we've already talked about what x cannot be in the denominator. You cannot have a 0 in the denominator. So what can x be that's going to give you a 0 down there? And here, this is a parabola that's moved down 3. This is an absolute value that's moved to the left 2 and down 1. And then this one is an exponential that's moved down 2. So there you go. So worst case, look at them in the graphing calculator or Desmos. Desmos is a little bit easier to read on those. All right, and then the next one. Go over 1, 2, 3, 4. Okay, so we're just going to draw a parabola that looks like this. And which equation goes with the graph? Which equation goes with the graph? Again, you could technically put all of these in Desmos and look at them, but you shouldn't have to. You shouldn't have to. You should know enough about your parent functions to see what's going on. The first one is y equals the square root of x plus 3. B is going to be y equals x minus 3 quantity squared. C is going to be y equals the square root of x minus 3. And then D is going to be y equals x plus 3 quantity squared. All right. Well, first off, this is a parabola. So which ones aren't going to work? Hopefully you see A and C. A and C are both arms. So this is going to be, so you should know the parent functions. This is going to be an arm that is moved to the, that's underneath there, that's moved to the left 3. This one is an arm that's moved to the right 3. So it's not that one. This one is a parabola that's moved to the right 3. And this is also a parabola, but this one moved to the left 3. So just by knowing our transformations and our parent functions, we shouldn't have to put any of these in a calculator or in Desmos in order to figure out. Hopefully you figured out that your answer is B, just by looking at it. Well, it can't be A and C because those are arms, and it's definitely B or D. This one is moved to the right 3. This one's moved to the left 3, so it has to be 3 to the right, so it has to be B. So hopefully you can see that without putting anything into the calculator, but worst case, you do put it into the calculator. All right. Next thing is a shortcut to graph absolute value. Absolute value equations. So a shortcut to graph absolute value equations. All right, so here's what you're going to do. First thing you're going to do is you are going to write it in transformation form. Write in transformation form. Transformation form. So just like you did on your last quiz. So it would be y equals a, and then inside, remember you got to factor b out, and then you're left with x minus h, and then you'll have your plus k on the outside. Remember, that's a vertical stretch of compression. That's a horizontal stretch of compression. That moves it left or right. That moves it up or down. If you have a negative out here, it flips it over the x. If you have a negative in here, it flips it over the y. Okay, so there you go. So there's that. Then what you're going to do is you are going to plot the vertex. Plot the vertex. And the vertex is your h and your k. So if that's like a -3, it would be 3. If that's a +3, it would be -3. So be careful about that. But your vertex is going to be hk. And then here's what you're going to do is you're going to multiply a times the absolute value of b. So the negative on the b doesn't actually matter. If there's a negative in front of the b, it's irrelevant. So a times the absolute value of b for the slope. So if a is negative, if there's a negative out in front of a, if a is negative, remember that's going to flip it down. So you're going to count down. And I'll show you what that means in a second. If a has a positive in front of it, if there's nothing there but it's just a positive, then you're going to count up. And then the denominator will make you go left or right. The denominator will tell you how many to go left or right. All right. So what do I mean by that? Well, let's check it out. So your first example is y equals -4 times the absolute value of x minus 3 plus 2. Now, I already know that's going to be upside down. So hopefully you can see, oh, maybe that's better. Hopefully you can see that it's going to go upside down. So let's check it out. So what is the vertex? It's already in transformation form. There is no b, there's nothing in front of the x, so I don't need that. So my vertex here is 3, 2. That's my vertex, 3, 2. Now we're going to look at the slope. So the slope, you would take -4, see it's a negative, that means we're going to count down, and then there is no b, so it's just basically a 1. So we're going to get -4, and we need a fraction, so we're going to put it over 1. So remember, slope is rise over run. This is going to tell you whether to go up or down. Since it's negative, you're going to go down 4. And then we're going to go left and right 1. Left and right 1, because we need both sections of it. So here's how it's going to work. We're going to go to 3, 2. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4. So we're going to go over 3 and up 2, and that's where our vertex starts. Over 3 and up 2. Okay? And then now we're going to go down 4. From here we're going to go down 1, 2, 3, 4. So go down 4. Go down 4. All right? And then we're going to go left 1 and put a dot, and go to the right 1 and put a dot. And now I have all my parts, and I can just draw my straight lines. And that's all I have to do. So whatever A is, positive or negative, you're using that. If there's a B there, positive or negative doesn't matter. You're taking the absolute value of B. So in this case, it's -4 times the absolute value of 1, which is -4. Slope needs to be a fraction, a rise over a run. So we're going to go down 4 and left and right 1. So that's the first one. The second one, if I have y equals 3 times the absolute value of 2x plus 4 minus 3. So the first thing we have to do is put it in transformation form. So I got to take that 2 out. And now we're left with x plus 2. All right, so what's my vertex? Remember, set that equal to 0 and solve and you'll get a -2. This needs to go to the left too. So your vertex is going to be -2, -3. All right, and then what is our slope here? Our slope is 3 times the absolute value of b, and b is 2. So this is going to be 6 over 1. So we're going to go up 6 and then left and right 1. So 1, 2, 3, 4, 5, 6. 1, 2, 3. 1, 2, 3, 4. Okay, so we're going to go to -2 and down 3. So right here, that's where we start. Go over 2 and down 3. Now I have to rise 6. So 1, 2, 3, 4, 5, 6. And then I'm going to go to the right one and to the left one. And there we go. And then you can just, using a ruler would be best. So if you have a ruler or a straight edge, you can draw your lines. So there you go. So that's what that one would look like. So it's literally going to go from the, look, this one goes from the origin and it goes to the right 3 and goes up 2. So that's where that vertex is. This one goes from the origin, it goes to the left 2 and down 3. So that's what that vertex does. So there's where the vertex is. And then hopefully you would see that those are going to make it skinny. And this one made it a little bit skinny, but the negative turned it upside down. So you should have had an idea of what it was going to look like anyhow. So one more like that. We're almost done. So if we have y equals 1/3 times the absolute value of -2x minus 6 minus 1. So the first thing we have to do is put it in transformation form. So I got to factor out that -2. So take out that -2 and you have an x plus 3. -6 divided by -2 is a plus 3 minus 1. So what is your vertex? Your vertex is -3. You're going to go to the left 3 and down 1. So it's -3, -1. All right. And then your slope here is going to be 1/3 times the absolute value of -2. Oops, I'm sorry. 1/3 times the absolute value of -2, which is just positive 2/3. And why doesn't that matter? Why does the negative on the inside doesn't matter on this one? Because if I was to flip that around on the y-axis, it would look like the same exact graph. So the negative on an absolute value doesn't make a difference, but the negative on the outside does, because it would go from a v going up to a v going down. Okay, so now this is telling me to go up 2 and then left and right 3. So go up 2 and you're going to go left and right 3. You have to do both, left and right 3. So we're going to go over to -3, 1, 2, 3, 4, 5, 6. All right, so we're going to go to our vertex, -3, -1 right here. And now this tells me to go up 2, and then I have to go to the left 3, 1, 2, 3, right here, and then to, to the right 3, and then to the left 3, 1, 2, 3. So you have a dot at 0, 1, and -6, 1. And then you can just draw your straight lines. And if you want, let me show you that in Desmos real quick. So if y equals, and then we have 1/3 And then we have the absolute value of negative 2x minus 6. And then on the outside, minus 1. So let's go in, and you can see where the vertex is at negative 3, negative 1. It crosses the graph at 0, 1 and at 0, negative 6. But the idea is you should be able to do this without a calculator. I just wanted you to see that it actually did work. All right. Last thing is finding k. Now, we've done this before, but before we did find k and you got some sort of point somehow. Like we said, f of 2 equals 0, or we said x minus 3 was a factor. So we got a point somehow. But now we're going to find k from a graph. Find k. So the way we're going to do that is we're going to use a point on the graph except the vertex. You cannot use the vertex except the vertex. You cannot use the vertex when you're doing this. All right, so if I give you f of x equals the absolute value of x plus 1 minus 2. So we're taking this absolute value, we're moving it to the left 1, and then we're moving it down 2. And if that particular graph is now transformed, so we're going to move it some more. So if it's transformed to f of x equals k times the absolute value of x plus 1 minus 2. So it's got some sort of vertical stretch or compression on it. We're not sure which one. And has a graph of, so here's the graph. So they would give you the graph. So they're going to give you the graph, and then we're going to pick a point on the graph to plug in and solve for k. So let me give you a couple points on this graph. Here, let me do it this way. And this is it. This is your last example. All right. So put a dot at 0, 0. Put a dot at negative 1, negative 2. And put a dot at negative 2, 0. So you're going to pick a point off the graph. It needs to be an obvious one. So again, you cannot use the vertex. So you could either use 0, 0 if you want, or negative 2, 0 to find k. So we need to find k. So the way we do that is just pick a good point, not the vertex. So pick a point other than the vertex. So pick a point other than the vertex. And plug in to solve for k. And plug in. And plug into the equation to solve for k. All right, so I'm just going to pick negative 2, 0. So negative 2, 0. So again, this is your x, this is your y. So that's a clear point on this graph, negative 2, 0. So go to your y equals k x plus 1 minus 2. So plug in a 0 for y. Plug in a negative 2 for x, so you'll have negative 2 plus 1 minus 2. Simplify that. Negative 2 plus 1 is negative 1, and the absolute value of negative 1 is 1, so 1k is just k. So you're just left with k minus 2. Get k all by itself by adding 2. So k is 2. So 2 is actually a vertical stretch. So k is 2. So here's what you're going to do. You are going to make sure that you use, first off, make sure you label number 37, make sure your name is on it, and you should have